Hello, my name is Ian and I'm a tutor at Chegg. Today we're going to be talking about the quotient rule. So both of these here are the quotient rule. H prime of x is the same as dy dx. So with the quotient rule, as you can see based off of the picture, is that you will be dealing with two polynomials over each other. So it's usually a rational function. So here we have f of x over g of x. Mnemonic people my class came up with was low, d high, so take the derivative of the high, minus high, d low. You can see that I have it set up slightly differently, but that's because a times b is the same as b times a. But you always have to take the derivative of the top on the left and the derivative of whatever is on the bottom on the right. So how I remembered it and why it's a little bit different is I know I have to do low, d high, minus whatever I didn't take the derivative of, and since there's only two options, it has to be low. So prime, times the not derivative, so leave it alone, of the top. And it's always all over the bottom squared. So here we have g of x squared, and it cannot equal 0. And this is because if a rational function equals 0, it is undefined in that spot. So let's start off with a problem here. This one is fairly simple, and then we'll move on to one that I found a little bit harder the first time I took or learned about derivatives. So based off of this definition here, and it might be good to write down as we work through these problems, what do you think you would do in this situation here? Well, if the first thing you thought was take the derivative, then you're right. So how will we go about this? For the sake of time, I took screenshots of the work I did so that we can get through both problems in the allotted time. So the first thing you need to do is set up the fact you will be taking the derivative. So you have the derivative of f of x over d of x. So then you have the derivative of this equation here relative to x. So this is telling me that you will be taking the derivative. Similarly, you could have wrote f prime of x equals. That means the same thing as df of x over dx. It's up to you which one you choose. I'm just going to be using this notation through the whole video, so don't get confused by that. So then the next thing we have to do is, well, the quotient rule. So we take our low, we leave the low alone, and then we take the derivative of the high, which here is x squared plus x plus 1, minus the derivative of the low, x squared minus x minus 1, multiplied by the top, and the top is left alone. And this is all over the bottom squared, so x squared minus x minus 1 squared. So before I go on to the next slide, try to take a moment to think how you would go around about taking the derivative here. And my hint to you will be the power rule. So now that I've given you a moment, if you paused it, to think about how you take the derivative here, it looks like the following. You have x squared minus x minus 1. That's left alone because you were not taking the derivative of it. The derivative of x squared is 2x. And that's because for the power rule, you bring the exponent down and put it in front of whatever the number is. So here is 2x. And then you have n minus 1. N in this case is 2. And that's not a very good 2. And 2 minus 1 is 1. So we're left with 2x there. And then the derivative of just x here being there's nothing at the top, 1 times 1 is 1, and you take away the x, therefore you have 1. So we then move on to the next portion where we have minus 2x minus 1. That's the same idea as the front, so you have 2x and then 2 minus 1 for the top, and you are left with 2x minus 1. And then we left the bottom alone, so x squared plus x plus 1. That's the same here. And the bottom, there's nothing we can do with it unless your teacher specifies that they want you to split the bottom up. Just leave it alone. It's fine. My professor never wanted me to, even though you can bring it further. So now we have to distribute and use the FOIL method. So take a moment to try and do that. So now that you've tried the FOIL method, I'll explain where I got all of these numbers here. So 2x to the third is by multiplying x squared by 2x. Negative 2x squared was by multiplying 2x by negative x. Negative 2x is by multiplying 2x by negative 1. So we've multiplied all of these by 2x, so now we have to move on to the 1. So I got positive x squared by multiplying x squared with 1, negative x by multiplying negative x with 1, and negative 1 by multiplying negative 1 with positive 1. And we know that the negative x and the negative 1 are negative because whenever you multiply a negative times a positive, you get a negative. So this is only for this first part here. We now have to move on to the second half. So similarly, we get the following by 2x times x squared gives us 2x to the third. 2x times x gives us 2x squared. 2x multiplied by 1 gives us 2x. And then we have to move on to the 1 to multiply out through this. So negative 1 times x squared gives us negative x squared. Negative 1 times x gives us negative x. And negative 1 times 1 gives us negative 1. So when we open the parentheses here, there is something very important I want you to notice, because sometimes, and very often actually, students will forget this. This negative carries through this whole equation, this half here. So if you have a positive, it'll become negative, and if you have a negative, it'll become positive. So you can see that working here. We originally had 2x to the third plus 2x squared, but now it's minus 2x squared. This plus is now a minus. This minus is now a plus. This minus is also a plus. And this minus is also a plus. So now we have to combine like terms. So we have 2x to the third here, and we have a negative 2x to the third. So we know they cancel out. Now we have negative 2x squared plus x squared, so that'll give us negative 1. Minus 2x squared, which will give us negative 3, and then another x squared, which will give us negative 2. So we have negative 2x squared, just to keep track of that. And now, since we did our work for them, we can cross them out. Now we have our x's. So we have negative 2x minus x is negative 3. Minus 2x is negative 5. Plus x will give us negative 4. Now, all that we're left with is our constants. So here we have a negative 1 and a positive 1, so they completely cancel out. So now we'll have negative 2x squared minus 4x over x squared minus x minus 1. And I just want to double check my work for the top here. So, yep, the positive 1 and the negative 1 will cancel out with each other. So we are left with 2x squared minus 4x all over x squared minus x minus 1. So to go through this one more time, we start with our equation. We then take the derivative of said equation with our low d high, high d low, all over the low squared. We will then distribute after we take the derivatives, so that's what's going on here. And then we will open the parentheses, change whatever signs are needed, and then we will combine like terms to get our end result here. So moving on to the next equation, it's a little bit harder than that last one. So I want you to think about how you go about this one, especially as we work through it, because this trips me up big time the first time I went through here. So you'll notice I have square root of x is equal to x to the 1/2. I highly recommend wherever you have a square root, you change it to x to the 1/2. That'll make using the power rule so much easier. So with that in mind, since we got to do the quotient rule as this video would imply, what do you think you would do from here? How about you try setting up the equation? So now that you've had a moment to set up the equation, you'll know that you'll have dh of x over d of x equals the derivative of the whole equation. So then we do high, or low, we have our low here, leave it alone, take the derivative of the high, which is x to the 1/2, minus high, so we leave it alone, d low, so we take the derivative of the bottom, and then we have the whole bottom squared. So I want you to try taking the derivatives of these, and then once you get that, press play again, and we will continue on the equation. So now that you have had the opportunity to take the derivative, this is what you should have afterwards. You'll have x squared plus 1 is equal to 1/2 x to the -1 minus x to the 1/2 2x all over x squared plus 1 squared. So wherever you have a negative, you want to bring that down, but you're multiplying it by x squared plus 1. So just take a second to think about what you should do here, because this is the step that tripped me up the first time I saw this equation. If you said that you should move the 2x to the 1/2 under the x squared plus 1, then you are absolutely right. So that's great, but now you have a fraction in a fraction, and that's usually very messy to work with. So what you should do here is multiply both sides by 2x to the 1/2, which is what I show here. This way, the 2x to the 1/2 will cancel here and here, and then you will, despite the fact that the 2x to the 1/2 cancels with this, you still multiply the 2x to the 1/2 by the 2x to the 3 over 2, and you multiply the lower 2x to the 1/2 by the bottom of this side. So take a moment to do that and see what you come up with. You should have come up with x squared plus 1 minus 4x squared all over 2x to the 1/2 times x squared plus 1 squared. So we can simplify this just a little bit further. All you need to do is subtract, or actually add, the 1 to the 4x squared. So then you'll have x squared minus 3x squared all over this part here. So the 2x to the 1/2 times x squared plus 1 squared. Hopefully this video has been helpful with getting you to understand the quotient rule a little bit more. I really think the mnemonic high d low, low d high should be helpful. It unfortunately does not help you with remembering that the bottom will always be squared, but nonetheless, these two problems, one was simple and one was a little more complex, so hopefully they have been assistance to you today.